Hello. So we will be studying here the first part of the question. This is a 2 mark question, and here a very concept of Wien's theorem will be applied. So this has been asked previously in the GATE exam. As you can see, let me just shift this. I will slide it down. Okay, it's gone up there. So let R be a region in the first quadrant of the XY plane enclosed by a closed surface C considered in counterclockwise direction. Which of the following expression does not represent the area? Now, as far as this question is concerned, we require two concepts here. See what has been asked here. So two concepts are required to solve this. One is your the Green's theorem. Okay. So Green's theorem's primarily statement is basically the classic statement of the Green's theorem is Green's theorem area holds to be in the region 1 into dx into dy. Okay. So the first thing is correct. Okay. As far as now, if you look here, okay, if we expand this Green's theorem in a counterclockwise direction, so we can check it like if we put the values for this, let's suppose, let me show you. The Green's theorem primary statement is this, okay? In a closed contour, P into d of x plus Q into d of y should be equal to this region delta Q by delta x minus delta P by delta y. So this is just the differentiation into dx by dy. Okay. Now, what we have this equation 1 and we always want this equation 2, right? From this. Now, in order to get this, okay, so this basically this same thing, compare equation 1 and 2, compare 1 and 2. So what do we notice? This equation 1 and 2. So that means dou q by dou x minus dou p by dou y should be equal to what? Definitely 1, na? Then only we will get dx into dy. Now this is 1 into dx into dy. That's why this first wala value it should be correct. So this is only possible. For example, okay, in the case 1, if I write the case 1 here, okay, case 1, in this case 1, if I set this p is equal to 0 and q is equal to x, then only I will get from the above equation this dou q by dou x minus dou p by dou y is equal to 1, right? Then only I'll get right, because if I set this p is equal to 0 here, this will become 0 and q is equal to x, it will become dou x by dou x, that is 1. Okay. So in the first case, first scenario, if you see setting of this into 1, so that means if I go back to my original Green's theorem formula, what was that? P into dx, right? Remember this, p into dx, p into dx plus q into dy gave me the result, right? In the closed contour, this was my first equation that I wrote, dou q by dou x minus dou p by dou y, that was equal to dx into dy. Now if I go back into the previous equation, so that means I have to set my q value as x and p value as 0. So here if I set q value as x and q value as 0, so that means this it becomes 0 into dx plus p into dy, correct? This will become 0 into dx and into p into dy. Once this becomes 0 into dx and p into dy, what is left with us? P into dy. P instead of p into dy, right? P we have substituted as 0. Sorry, p is 0, right? 0 into dy and q is as x, right? So what is the equation? X into dx, right? So we got the equation as x into dx. Uh, uh, so that means my area would be equal to. So this was my question was dou q by, okay, yeah. What was the question? This was dou q by dou x minus dou p by dou y is equal to 1. Very good. So if and my final equation there is p into dx, right? So that means I have to substitute p value as 0 and q value p into dx, right? So p value as 0, correct here. So here it will become 0 into dx plus q value as x into dy. If I substitute here, right? Here in the left hand side of this equation, so I get an equation, right? I get an equation here as this will become left hand side of this will become 0 into dx instead of q over there, x into dy. Keep, sorry, from beginning. Okay, just a second. Yeah, here we were. Yeah, instead of there, it will become 0 into dx plus x into dy is equal to my this region, right? Which is in turn dou q by dou x minus dou p by dou y, okay, which dx by dy, which is also equal to my region, na? This which is also equal to my, see, 1 into dx by dy. Or in short, what I got, this is for the area using the Green's theorem. So what I got area. So just this is just one more question over there. Okay. So what I got this area as, area here I'll get as this value, right? This region is dx into dy as x into dy or a closed contour C. So this is also correct. Okay. Now let me check for this y into dx wala value. Same for y into dx. How do you get y into dx there? You need the value to be 1. This value you need this value to be 1. In order to get this value to be 1 again, so you definitely, if you are setting q is equal to 0, okay, and p is equal to minus y, that's the only possibility you will get in this differentiation. If you put here, if you are putting q is equal to 0, this value becomes 0 over here. And if you are putting p is equal to minus y, what happens? Minus and minus becomes plus, right? Over here, minus and minus becomes plus, so it will become 1. So that means the only chance is that, okay, so if you are putting in this equation, so that means the only chance here is you are putting this as q as 0, right? Q as 0 and p equals to minus y, right? So this is 0 and p equals to minus y. So my equation is c minus y into dx, right? But what is written over there? Y into dx. So this is wrong. So this is not the correct expression. A is the correct expression, B is the correct exception, and C. So as far as the C is concerned, see, I know that, okay, both these A and A, see, both this area is also contour of x dy plus contour of C minus y dy, correct? This is not, so that means this will give me twice the area, right? Because this is also 1A and this is also 1A. So this is, that means my area would be also equal to half of this. If I take this half of, okay, I can write this as the classic formula, half of x dy minus y dx. So this is also correct. So that means the only thing is this is wrong. Okay. Now let me go to this question number 1 given over here. So till now we have seen the Green's theorem, how I am applying there. Now let's go to the line integral formulas. Here also the same thing. We will be using the Green's theorem. What we do is the same thing. P dx plus q dy is equal to r of dou q by dou x minus dou p by dou y into dx by dy. So when you saw this question, so but here in this question, you remember this is, these type of questions are commonly appearing in the GATE examination, and here the values of these questions, for example, the primary concept is, first concept is that we have to apply the Green's theorem. Okay, and there is a vector line integral and area in the polar coordinates. So here basically a vector field, you have seen this question, a vector field would be represented like this, C of F into dr. Okay, what is the value of F? F value, force value is given over there, Pi plus Qj. Okay, this value is given. Similarly, your R would be given as dx into I plus dy into j, and its dot product F dot dr would be equal to the contour of this P dx plus Q dy. Okay, this is the basic line integral. The basic line integral that we'll be using. Basic line integral. So here again, what we can do here, we can apply the Green's theorem again. P dx plus Q dy is equal to double integration. Okay, region dou q by dou x, remember this, minus dou p by dou y, okay, into area dA. dA is what? dA is nothing, dx by dy, dx into dy, x into y. This is two-dimensional area. Okay, now here, see, the value of f, if you see, it is given in the question. F is given minus yi plus xj. If you compare it with the standard equation, you will get, right? So x value, right? So now curl of this field, if you go for the curl of this field, so your f value is given here. F is equal to minus yi plus xj, correct? This is given. Now here you see dou q by dou x, right? Minus dou p by dou y. This value should come as 1, right? Now if you compare this equation, what is your q value? What is your x value? Dou q by dou x, right? If you look at the q value there, this is your p and q, na? See, if you compare this, this is your p and this is your q, right? So p becomes your minus y, q becomes your x, right? In the above equation, whenever you are writing the equation, so this equation you apply the Green's theorem, right? This is your Green's theorem. C is equal to p into dx, right? Plus q into dy. Okay. This is equal to double integration of dou q by dou x minus dou p by dou y into dA. So here, if you compare this equation, you have this f here. F value is, so you have, from this f you get the p value. P value is the first value minus y and q is the x value. Now this dou q by dou x, that means dou x by dou x minus dou y by dou y, okay, should be equal to 1. But q is x, right? So this becomes 1. But what is your p value there? So p is your minus y and q is your x. Okay. So if you see over there, dou q by dou, if you just calculate these values, so what are the values you are getting? This should be equal to, so dou p by dou y, right? So this is a different vector over there, because p value you saw, p value is equal to what? Minus y, and q value here is x, right? Q value is x. So x and x 1. So this is your 1 and this is your minus p. Uh, this would be 1. Oh, sorry. Q value, if you see over there, is just a second. This is okay. I'm just confusing you a lot. Just stop.